Welcome to another episode of Terry's Notes, and today we are going to be looking at solving simultaneous linear equations using the elimination method. Right? I did a previous video with substitution, so we're going to be looking at elimination. So we're looking at the June 92 paper. We have to solve these simultaneous equations here. 4x minus 4y equal 2 and 7x plus 2y is equal to 17. Now, here how we do this. First thing we need to do is to label our two equations. So we have equation 1 and we have equation 2. Now, when we say elimination, we can either eliminate x or we can eliminate y. Now, in this first equation here, equation 1, we have 4y minus 4y, and in the second equation we have 2y. So what we do in the second equation, we multiply by 2, right? So that is equation 2 multiplied by 2, which will give me 14x plus 4y, which is equal to 34, right? And we call this equation 3. Right, now I'm just going to write back what equation 1 is, which is 4x minus 4y is equal to 2, right? And this is equation 1. Now, what we can do, we can eliminate the y's, right? Now, how do we do that? We have plus 4y here and minus 4y here. So all we need to do is to add the two equations, right? So we say equation 3 plus equation 1, right? And that'll give me 14x plus 4y. 14x plus 4x will give me 18x, and 4y plus minus 4y gives me 0, right? And then 34 plus 2 gives me 36, right? Now it is going to seem a little strange when you now start solving equation using elimination, but with some practice you'll be able to get it. So 18x is equal to 36, therefore x is equal to 36 over 18, so therefore x is equal to 2. So we've solved for x. Our next step is to substitute x equal 2 into any one of our equations. Into, let's see, we want to solve for y. So we can use equation 1 into equation 1. So 4, in this case x is 2, minus 4y is equal to 2. So that is 8 minus 4y is equal to 2. And we can write 8 minus 2 is equal to 4y. 8 minus 2 is 6, is equal to 4y, and therefore y is equal to 6 over 4, therefore y is equal to 3 over 2, right? And like I said, we can always substitute our values of x and y into the equation and see if they work, right? So let's take equation 1. So 4 by 2 give me 8 minus brackets 4 multiplied by 3 over 2, and that'll give me 2. So it does satisfy the first equation. Let me try it in the second one. 7 multiplied by 2, which is 14, plus brackets 2 multiplied by 3 over 2, and we get 17, right? So therefore x and y satisfies both equations. right? Look at another example. So we have 5x plus 6y equal 37, 2x minus 3y equal 4. And this is January 2006. A question from the January 2006 paper. So again, we label the two equations as 1 and 2. And we have to decide what are we going to eliminate. Okay. If we look at the equations, we have 6y here and we have minus 3y here. So the easiest thing to do is to take equation 2 and multiply by 2. So that will give me 4x minus 6y is equal to 8, and we call this equation 3. Right? So equation 1 looks like this: 5x plus 6y equal to 37. Right? And that is equation 1. So we can eliminate the y's by adding the two equations. So we say equation 3 plus equation 1, right? And you can look at it as just an addition we are doing here. So 4x plus 5x gives me 9x, and minus 6 plus 6 minus 6y plus 6y gives me 0. And then we have to take 8 plus 37, and that gives me 45. So therefore x is equal to 45 over 9, and therefore x is equal to 5. Right? So now we have to substitute x equal to 5 into any one of our equations, into, let's look for an easy one, into, let's say, equation 2. Right? So 2 multiplied by 5 minus 3y is equal to 4. So that's 10 minus 3y is equal to 4, minus 3y is equal to 4 minus 10, minus 3y is equal to 4 minus 10 is minus 6, and y is equal to minus 6 divided by minus 3, which is equal to 2. Right? And again, we can check our answers by substituting it into the original equations. So let's say 5 5s are 25 and 6 2s are 12. So 25 plus 12 will give me 37. If I substitute it into the second equation, we get 2 by 5, which is 10, and 3 by 2 is 6. So 10 minus 6 is 4. So the solution x equal 5 and y equal 2 satisfies both equations. We have another question here from the January 2012 paper. And so we label our two equations, equation 1 and equation 2. And we realize that we have a 2y here and a minus 2y here. So easiest thing to do is to take equation 1 and add it to equation 2. Right? So 3x plus x gives me 4x. 2y plus minus 2y gives me 0. And 13 minus 1 gives me 12. So therefore x is equal to 12 over 4. Therefore x is equal to 3. Then you have to find y. So substitute in x equal 3 into equation, let's say 2. Now you can substitute into any equation, keep that in mind. So we have 3 minus 2y is equal to minus 1. So minus 2y is equal to minus 1 minus 3. Minus 2y is equal to minus 4. And y is equal to minus 4 divided by minus 2, which will give me 2. Right? And again, you can substitute into your equations to see if they are satisfied. All right, let's move on. All right, so we have two equations again. We have equation 1 and we have equation 2. So we can either eliminate the x or the y's. Let's eliminate the x's. So I'm going to take equation 2. I'm going to multiply it by 2, right? And when I do that, I end up with 2x minus 4y is equal to 2. I'm going to call that equation 3. And let's write back equation 1. So we have 2x plus y is equal to 7. Right? And we can eliminate the x by subtracting the two equations. So we say equation 3 minus equation 1. Right? So 2x minus 2x will give me 0. And minus 4y plus, minus 4y minus y gives me minus 5y. And 2 minus 7 gives me minus 5. So therefore y is equal to minus 5 over minus 5. So y is equal to 1. Right? And so we're going to substitute y equal to 1 into equation, let's say 2. So we end up with x minus 2y, which is 1, is equal to 1. So x minus 2 is equal to 1. X is equal to 1 plus 2. So therefore x is equal to 3. And again, you can substitute into your two equations to show that your solutions are correct. All right, now let's look at this June 2012 paper. Now this one is slightly tricky, right? Because we have 3x here, we have 2x here, we have minus 2y and 5y. So we can't just multiply one equation by a number, right? What we have to do, we have to manipulate both equations. So we're gonna call this equation 1, call this equation 2. Now I want you to pay attention to this solution in particular, because it could be kind of tricky. All right, so let's decide to eliminate one. We're going to either eliminate x or y. So I'm going to choose to eliminate x. All right, so you have 3x here and you have 2x here. So let's take equation 1 and multiply by 2. If we do that, we end up with 6x minus 4y is equal to 20. And I'm going to call that equation 3 now. Now I'm going to take equation 2 and I'm going to multiply by 3. Why? Because I want to get 6x. So this will be 6x plus 15y is equal to 39. So the next step is to subtract both equations. So equation 3 minus equation 4. That'll give us 0. 6x minus 6x is 0. And minus 4y plus minus 15y gives me minus 19y. And 20 minus 39 gives me minus 19. So y is equal to minus 19 over minus 19, which is equal to 1. Now substituting y equal to 1 into equation 2. Sorry, equation 1. So that'll be 3x minus 2 open brackets 1 equal 10. So 3x minus 2 is equal to 10. 3x is equal to 10 plus 2. So 3x is equal to 12. Therefore, x is equal to 12 over 3. Therefore, x is equal to 4. Right? And we can take our values of x and y and substitute it into both equations to see if they satisfy each other. Let's look at the June 2014 paper. We have to solve two simultaneous equations. So we label our equations 1 and 2. And we need to decide what we are going to eliminate. Okay. So we can either choose to eliminate x or eliminate y. So we're going to take equation 1 and multiply by 3. And that will give us 6x plus 9y equal to 27. And we label that as equation 3. And then we're going to take equation 2 and multiply by 2. That'll give us 6x plus 9y, 6x minus 2y equal to 16, and label that as equation 4. Then we are going to subtract both equations. So equation 3 minus equation 4. And we get 6x minus 6x gives me 0. And 9x minus 2y gives me 11y. Okay, make sure you understand what I'm doing here. So 9y minus 2y will give me 11y. Right? Which is equal to 27 minus 16, which will give me 11. So therefore y is equal to 11 divided by 11, which is equal to 1. Then we need to substitute y equal to 1 into equation, let's say 2. So therefore 3x minus 1 equal 8. So 3x is equal to 8 plus 1. Therefore 3x is equal to 9. So therefore x is equal to 9 over 3. Therefore x is equal to 3. Okay.